This video we're going to talk about the fundamental counting principle. It's a pretty fancy name of just how to count things. In the previous video we talked about tree diagrams and how to organize them in a tree diagram. So it's going to be pretty similar to this, except you'll see in the second example a tree diagram is a terrible option for this. So in the NFC South, I've got the first example. It says in the NFC South, in the National Football League, there are 4 teams: the Saints, Panthers, Buccaneers, and Falcons. So in how many different ways can the teams finish first, second, third, and fourth in their division? And so if you recall from our tree diagram video, we had, there were 4 different ways. Oops, that's not what I wanted. There we go. There was 4 different ways that teams could finish first. So this would represent the Saints, the Panthers, the Buccaneers, and the Falcons. And then there were 3 different ways teams could finish second because the Saints have already been picked. And so this would be Panthers, Buccaneers, Falcons, and then we had 3 choices for each one. And then once first and second were picked, you had 2 choices. So the fundamental counting principle says, well, let's not make a tree diagram, but let's basically figure out what that tree, how many different branches on that tree diagram there would be. And so the way we do this is typically what you'll see is you'll say, well, what about first place? And then what about second place? And then third? And then fourth? So how many different teams can we pick to get first place? So there are 4 different teams that could get first place. And then once we've chosen that team, let's say it was the Saints because they tend to get first place. We've already used the Saints, and so we are going to say, now how many teams are there? Well, there's only 3 teams left, and so we have 3 teams to pick from. So once we've picked first and second place, now let's assume the Panthers got second place, then there are 2 teams left to choose for third place. So we only have 2 choices left for third place. And then once we have picked first, second, and third, then in fourth place will be that remaining team. In this case, it would be the Falcons. So what that means is we're going to have 4 branches in our first part of the tree diagram, 3 branches off of each of one of those 4 branches, and then 2 branches off of each of those. So basically what we're going to do is we're going to multiply all these together is what I'm getting at. Every time you do another iteration of this tree diagram, it's basically you're multiplying by how many choices you have remaining. So 4 times 3 times 2 times 1 is 24 ways. So there are 24 different ways that the 4 teams in NFC South could get first, second, third, or fourth. All right, so this could have been done in a tree diagram. It would have been just fine. You saw that I was almost, I was halfway done basically to making the tree diagram. But there's going to be problems where this is not a very good option. And so this one, it says a license plate consists of 3 number digits followed by 3 letters. How many license plate combinations are possible? A quick side story, I remember driving down the street one time and I saw somebody had a customized license plate. Obviously we're not going to include those in our count here. But I remember their license plate was like BB888B8. And I'm thinking, man, I wonder if this person likes to drive fast, and then when the cops, when they outrun the cops, they're like, well, you don't know my license plate because there's a bunch of B's and A's. Anyway, so license plate has 3 number digits followed by 3 letters. So how many choices do I have for these number digits? And then I'll just put, there's more than A, B, C, but we'll talk about this in a second. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0. So how many number digits are there? There's 10 choices for that first one. And you can repeat numbers. And so you could have like 1, 2, 1. So there's 10 choices for the second and 10 choices for the third. So for the first part of the license plate, it would be 10 times 10 times 10. And then for the second part of the license plate, how many letters are there? Well, there are 26 letters in the alphabet. And for that first letter, you have 26 choices. For the second letter, you still have 26 choices because you can repeat letters. And for the third letter, you still have 26 choices because, once again, you could repeat letters. So one example could be 346 MPR. That could be a license plate. Or it could be 151 VVV. Those are two different license plates possible. We're not going to list out the whole sample space because the answer to this is 10 times 10 times 10 times 26 times 26 times 26. That's a lot. I'll pause it here. I'll pull up a calculator just a second. Okay, so there's my calculator. So I'm going to do 10 times 10. Let's see. 10 times 10 times 10 times 26 times 26 times 26. And what do we get? Holy smokes. We get 17,576,000 different license plate combinations. So 17,576,000 different license plate combinations. I don't want to make a tree diagram for this, so this would be a great time to use the fundamental counting principle. Now there are some restrictions. We're not going to worry about this for this example, but states don't want swear words on their license plates, so there are certain combinations that they might not want. So it would be a little bit less than this, but there's also options where there are some personalized license plates. So holy smokes, there's millions of different options for license plates out there for each state. And then a state like California, they don't do 3 numbers followed by 3 letters. They have the stuff intermixed, so it's going to be even more. All right, so this is the fundamental counting principle. You multiply up how many choices for each different option you have, and you get the total sample space. Well, you get the total number of things in the sample space.